Hi, my name is Caleb Lindsay. This is going to be my week 3 submission for FTH 202. Today's date is January 31st, 2026. And before we begin, I'd like to just announce that I have no ammunition in my workspace, and the firearm that we're going to be working with today is clear. Nothing in the chambers, no obstructions in the barrel, clear, and we'll go ahead and begin. So now that I've got the side plate off of this thing, we're going to talk about the hand, the sear, cylinder stop, and the hammer strut. Okay? I'm going to talk about basically what kind of malfunctions or failures you're going to see in this firearm if any of those components fail. And this is all just going to be based off of our module 3 or week 3 lecture. The first component that we're going to be talking about is going to be the hand, which is this guy right here. So what's happening is when you squeeze your trigger, it's going to pivot on this pivot or this trigger pin, which pushes your hand up. Now the top of the hand is going to make contact with the ratchet pad on the backside of the cylinder, causing the cylinder to rotate, which just gets each chamber in line with the firing pin and the bore of the barrel. If there's not enough contact between the hand here and the ratchet pad, it's going to end up slowing down the action itself, and then you're going to end up with a failure to lock. The next component we're going to be talking about is the sear. It's kind of hard to see in here. It's tucked up behind the hand because I have it in the cocked position. Okay, the sear is a part of the trigger that comes off the back end, and it makes contact with this very far tip of the hammer in the hammer sear notch. Okay, when those parts are aligned, they basically mate together, and the sear coming off of the trigger retains the hammer in the cocked position. Now, when that sear gets worn down, it can cause quite a few problems, but the biggest one to me is more of like a safety concern. Okay, when it becomes worn, there might not be anything to engage with the leading edge of the hammer into those notches or into that notch, and you're going to end up having like a failure to cock because there's nothing to retain the hammer. Okay? That could be a problem if you're trying to carry it around in the cocked position and there's not very much material to mate with in that sear notch in there. This hammer might just fall forward firing the pistol, which is a big concern. So basically, this is as much as it is functional, it's also kind of a safety device. So the next component we're going to talk about is a cylinder stop, which is just this little guy in here. It's kind of recessed right in front of the trigger, and it protrudes through the frame and catches these cylinder notches right here. Okay, if this becomes worn, this part that's coming through the frame right here, and it doesn't catch these cylinder notches, you're going to end up with a failure to lock. Okay? That's what's happening really. Basically, it stops the cylinder right where it's supposed to, so it's in line with, again, the firing pin and the bore of our barrel, and that's the locked position of this thing. So failure to lock. It's also kind of a timing issue. If this thing keeps, let's say it just keeps rotating just a little bit past where it's supposed to stop, you could end up with a big timing issue, because like you could send your hammer forward to try to light up that cartridge, and instead the hammer could end up hitting the firing pin, and the firing pin going into like the side of the cylinder or something, and then you'd have a failure to fire at that point. But the big one that I see is a failure to lock. And then the last component I'm going to talk about is actually the hammer strut. So it's actually the metal bar that's in here that the spring sits on. Now combined, the strut and the spring together is what retains or keeps this potential kinetic energy that's going to send the hammer forward in the event that you actually fire the firearm. But the strut is what is kind of keeping all of that energy like stable against the hammer. Okay. Well, along with like the sear and everything, but if basically if this strut was gone or it was broken, it snapped somewhere, and you had to replace it, you'd end up with a failure to cock because there's no resistance to put this hammer against. It would just kind of be free floating at that point. So those are the 4 components that we're going to talk about this week, and we'll go ahead and move on. So next, on part 2 of this, we're going to go ahead and measure our barrel twist rate. Okay, so I've kind of got the setup right here. What you'll need is your cleaning rod on a bearing here. I've got it taped up, so I've got a flag and an extra place to mark because I already suspect that it's going to go past this brass part. I've got my jag and a patch so I can catch the barrel and start feeling that twist, right? Something to mark with, tape measure to measure our measurements that we're going to get down here. Something to write with so I can write down all my measurements. And then I've got the pistol kind of chalked up here inside of my little vise. So that way we've got a good grasp on the firearm to get this measurement. So because I'm going to be pushing that rod through the barrel and watching that flag twist, and I'll get the measurement here in just a second. Okay, so I've already got my jag and rod and everything inserted into the barrel. What I'm going to do now, and I've got my starting point marked right here. It's kind of underneath the patch. It's on there. What I'm going to do is I'm going to insert this setup kind of into the barrel. It's going to engage with the threads, and what I want is my flag that starts at the 12 o'clock position. I'm trying to get like a 1/8 turn into this, so like a 45-degree angle on the flag, and then I'll make another mark and we'll do some math from there. So let me go ahead and push this through here a little bit. Right about here. Okay, I'll take my Sharpie, get another mark right here, and now we'll measure. So I didn't put all this on camera as I was doing it, but basically I measured that out. I got about 2 inches, right? So I did the math real quick. So I got 2 inches, and it took me that 2 inches to get about a 1/8 twist, or to get to that 45-degree angle. And from there, I'm just going to multiply the 2 times the 8, which gives me 16. The 1 carries over to over here. So it looks like we've got a 1 16th inch twist rate on this pistol here. And that's it. That's going to be everything we need to do for our week 3 assignment.